So hello everyone, welcome to another machine learning project series video. Today we're gonna be building a house price prediction model. So let's start. So here the steps are coming that I'm gonna follow to build this machine learning model. First is coming data import. The data that I'm gonna use to build this model, I'm gonna simply import this data set on this step. After that, I'm gonna jump into EDA, also known as exploratory data analysis. EDA is needed to better know about that data set. We're gonna explore different things of that data set. We're gonna see also info, describe, or we if we we'll also check like is there any null value or not, and if all everything is correct, that will then we're gonna be jumping into feature extraction. For feature extraction, like on dataset, all the features and all the data points is not needed. We're gonna maybe extract some of the individual features over there, and after that we can jump into pre-processing. Here again, pre-processing is not mandatory, it is optional. We can do, or we we don't need to do that, because it depends on the data set. If the data set is needed pre-processing method, then we're gonna use. After that, we're gonna go through model building process. The data points or data values that we are getting from feature extraction, or overall process, we're gonna feed into that our model, and after that we're gonna build our model using those data points. After that, we can jump into model comparison also. Here model comparison, I think it's not mandatory. Maybe on the last I'll gonna do, and I can also skip those that particular step also. Now here the step, like after outcome, after our prediction model is done, what we can do after that, here is like I divided into two steps. Like first we can measure the R square score, or we can also like mean absolute error, we can also measure. MAC also we can measure. After that, step 2 also will come, like we can plot or predict the actual price of that of that model. Like we can use matplotlib to visualize like the graph to see the plotted predicted model or the actual price. Now, here are the ML model that can be used for our data set. Like as our data set is continuous, because it is predicting mostly the price, we can use all those model here, like linear regression, decision tree, KNN, support vector machine, XGBoost, and gradient boosting machines. Like for here, maybe I'm gonna use the XGBoost over here, like XGBoost regressor, and for all those other technique will also be also work better, but we need to check which one is better for our ML model. So let's now jump into our Jupyter notebook. So to train this model, we're gonna be following those steps like data import, EDA, feature extraction, pre-processing, and model building. So let's right now jump into our Jupyter notebook. For here on our Jupyter notebook, what I did, I simply imported all the libraries that we need to build this price prediction model. First, what I did, I imported NumPy and I took pandas, and after that, I need a matplotlib for PLT function for the graphs and other visualization. And after that, I imported seaborn as SNS, and from sklearn dataset I am taking the Boston price dataset, and from sklearn model selection I am simply importing the train test split. And here for our model I am using the SGB regressor, as it is a regression model. So from XGBoost I am importing that one, and from sklearn I am importing the matrix. On the last I will measure the accuracy or something like R square error or mean square error of that particular model. So what I am doing here now, I took a house underscore price underscore dataset, and from sklearn dataset I am loading the Boston price dataset over here. And after that, what I did over here, I simply just print using print function. Like there are many data coming over here using an array format. We do not need all those data set. We maybe need some unique values from this data set that will be needed to predict the price for that particular house. Like there are many features over here, and for all of the features it is written, like the description is written over here. And after that, what I did, I took a PD data frame over here, and I initialized a house price underscore price data set. And for all those data I am accessing, I took columns. For all the columns I am taking from that data set I am taking the features name only, like CRIM, ZN, INDUS. And after that, what I took, I simply did the call the data set using head function. So for head function, as you can see, first five rows are visible over here, and the respective columns are there. For columns, we have CRIM, ZN, Indus, CHS, NOx. We have also age, and what all those means tags also we have like those have a particular meaning over here. So from dataset I already wrote in a manner that we can understand what is happening over here. So like all those are features, and here are description written. And for CRIM, it means per capita crime rate by town. Indus also we have like proportion of non-residential non-retail business occur per town. We also have NOx, also nitrogen oxide concentration. And we have age over here, proportion of owner occupied unit built before 1940. And we have tax like property tax, tax rate per $10,000. And all these are written. We have also price. We need to add this price over here for prediction. So what I can do over here, I'll simply take that house price data frame over here. I'm gonna simply write it. And for here I can use like price I can call over here. So for if I take price over here, I need to add a particular column that is name price. So for house price, we from dataset we are taking the target features over here. So I'm gonna simply run it, and if I run this again, it should work. See, price are coming, all price are here. Like for price, median house price is $1,000. Like it's written on the dataset as target, but we are initializing as price over here. So what I can do after now, I can simply take this data frame, and I can simply take a data variable and simply push that onto data. And after that, I think the data dot head should work. The reason I did it before, because most of the time we are calling this data, we don't want to call those house underscore price underscore data frame for each time. It will it will simply gonna waste our time. So after that, what we can do, we can go to the EDA process. Our data import is done. For EDA process, I can simply use a data.shape over here. If I use data.shape, like 14 columns are there and 506 rows are there. So after that, what you can also do, you can use data.info over here. So if we use data.info, like all those 14 columns are coming, it is starting from 0 and ending on 13 index. For Python index, it's always start from 0 only. And for each one, we have 506 data points, like rows number, and all are non-null. It's showing like there is no null value. We will also check a particular null value using is NA function later. So for d types, we only have the floating number. There are no other data types, like it is classified only one terms only. So what I can do after now, as it is in numerical form, floating number, I can simply use data dot describe over here. So if I use data.describe, many things is coming, like minimum value, it is starting, and maximum values are there, and with respective 25%, 50%, 75% also there. Like for price, as I can see, if I check minimum value is 5.000 minimum price, and the maximum value is 17. And after that, what we can see, sorry, maximum value is in the last, like 50 it is coming. And what you can check over here, mean value also you can check, 22.53 something is coming on average. And all other thing is there. Like for tax, minimum tax is 187, and maximum is 711. From this describe function, we can see from outside many things we can see. Now what I can do over here, I'll go to simply check verify is there in null value or not. For that, I'm gonna be using is NA function. If I use if NA function, As you can see, for first 5 rows and last 5 rows, it is coming all false, which means that there is no null value for first 5 and last 5 rows. But I don't know in between is there any null value or not. So what I'm gonna simply do, I'm gonna use a sum function. If I use sum function all for all the particular individual columns, it is coming as 0 0 0, which means for each column there is no null value. If I call the sum function again, it shows 0, which means there is no null value over the data set. And after that, what we can do, we can simply plot a correlation matrix, using heat map sorry plot core, like correlation. So what I can do over here, I can simply call data.cor correlation. I can check. So for each of the columns, it is coming all the correlated values. But what I can simply do here, I can simply take a SNS heat map. So for that, I'll gonna use fig. I'll define the figure over here, I'll get plt.fig. And for fig size, what I can do, I can take any particular fixed size. For here it will be a little bit big, as you can see. So I can take a height and width as a 10 10. And after that, sorry, here will be not fig, it is a fixed size. And after that, what we can do over here, and sorry, also it will be figure. And after that, we can also simply use SNS heat map. And using heat map, I'll gonna use a data dot. I'll call this one, I need all the correlation. And for the c bar, I'll use a true over here, boolean true. And after that, I need it as a square as true. And what we can do, we can also define anot. I need anot also as true. Anot is it will show all those number inside the heat map. And after that, I think it will be enough. Let's check once. Okay, sorry, I need to this one. Yeah, it's showing for each of the individual columns, it is showing the heat map over here. Let me a little bit zoom out over here. Yeah, right now it's okay. From in between, we are having 1 1 1 1 1 1 as diagonal. It means for CRM CRIM, here diagonal it is coming CRIM. It once means all the data is same, so that's why it is coming as 1. And for here, the scale is given, the data that is not that much correlated will go on the dark side, and the data that are mostly correlated will go on the light color here. And we can see there are many dark values which are not correlated to the another columns over here. So from is SNS, for this heat map, we can see many correlations over here. So what will help in our correlation, that we can simply check which value is correlated with another, and we can simply use it on our machine learning model. We have on our feature extraction, it is very helpful. So what I can do here, our EDA process is basically done. I'll go to simple splitting the data set over here. So for splitting the dataset, what I can do, I can take a x and I also can take a y over here. For x, what I can do over here, I can simply call data, and I'll use the drop function. Simply from here, I'll take columns. And for columns, I want to drop the price over here. And after that, what I can do, I can write axis as 1. I want to drop the column over here. And for y, what I can do, I can simply take the price column over here. So let's check once. I will print it down, print x. Yeah, without the price column, or all column came over here. And if we check y, with only the price column came here, no other columns are there. So what I want to do here now is like simply let me get the data dot head here. So I simply splitted the dataset into two from like for this side, all the columns that are coming, all those values I will feed into our machine learning model and check it is predicting the price over here. And for price I got a y over here. The only value that I will predict is y, that means price. So here splitting is also done. What I can do over here now, I can use the train test split. So here as we go to the first over here, as you can see, I already imported from sklearn model selection. I imported train test split over here. I'll gonna simply copy this one, and I'll split into four forms like x train, x test, and y train, and y test. For here I'll take a train test split and gonna use that function, and for that function I'll gonna feed x and y over here. After that, what I can do, I can take test size, and for text size what I can do, I can take a 0.2, any value also you can take. Like this is the percentage which it will gonna split, like 20%, 30%, or 40%, which means 0.2, 0.3, or 0.4. And for random state we can use like 1 or 2 or 3 also we can use. So I'm gonna simply use as 2. It will gonna randomly take the values over here. So I'm gonna run it, and after that what I can do over here, I'm gonna simply check it is properly divided or not. For that I'm gonna take x train dot shape over here, and I can also take x test shape over here. As you can see, our data is properly divided. Like for first x train we have 13 columns. We have also x test which also have 13 columns, and for all those individual have different values. Like it is divided into 80% and 20%. Like 80% are here, 404 values are on x train, and 102 are on x test. So like our train test split is normally done. What I can do, I can go to ML model building process. So for this process, what I can do over here, I'll simply take model, and for model what I can take, like I will take this XGB regressor because our all those values are in continuous form, all those are not categorical form. So that's why any regression model will gonna work here. So I'm gonna simply paste it over here, and I'll call it as a function. So after that, what I can do, I'll use a model dot feed function over here, and using model dot feed I can use a x train and a y train. So simply run this one. As you can see, our model is properly fitted. There is no like underfitting or overfitting issues over here. So what I can do over here, I can go to prediction. As our model building process is done, so I'll go to prediction over here. For prediction I can take data prediction, sorry. Mm, for data prediction, what I can do, I can take model dot predict over here, and using that model dot predict I will take explain. Now for here, let's print the prediction. I'm gonna take this one, data underscore prediction over here, and as you can see, like all those prediction are coming for this model. Now what I can do, I can measure the r square or r square and mean square error over here. I can simply measure it using the library that I called over here using matrix. So what I can do, like now right now, just I will take score underscore 1 first score, and I will take matrix, and from matrix I will call r2 score over here, and using r2 score I'm gonna simply take y train. I'm gonna use this measuring for R2 score using Y-train, and later after this one we can measure using the test data. I'm gonna take this one, and I can take like data prediction for score 2. I'm gonna take mean square error. I take mean here. I think I should measure not MAC mean square error. I should measure mean absolute error. Like I'm gonna simply change it to mean absolute error. Uh, okay, absolute underscore error will come over here. Sorry. And after that, what you can do is I'll simply call Y-train again, and I'll validate over the data prediction over here. There is a error over scalar matrix as an attribute. Okay, I think something wrong I written over here. Mean apps. Okay, it's wrong. Yeah, it's working. So what I can do over here, I will simply print it down. Like what I can say, I will just say R square error over here, and simply what I'll do over here, I'll gonna print it down. So I'm gonna feed score underscore 1 over here, and after that what I can do for mean absolute error, I'll just use mean absolute error, also known as ME, and after that error I will call. Here I'll take score underscore 2. Let's print it. Okay, sorry, here will be 2 not 1. Let's run it again. Yeah, like as you can see, R square error and mean absolute error is coming. Like R2 score is coming around 0.99, which means we got around 99 percentage of accuracy. And after that we also got mean absolute error, which is came which comes so much low on the training data, like 0.0091, which is a little bit low. We can, what we can do after that, we can simply go to a check, like a plot check using matplotlib. So let's go to pt dot. I'm gonna use a scatter plot over here, and for scatter plot I'm gonna take Y-train again, and I'm gonna validate over the data prediction over here. And as I took data prediction, what I can do, I'll take x-axis, x label as price. Sorry, I'll take actual price, actual price, and I'm gonna also check the prediction price. For Y label, I'm gonna simply take predicted price over here. After that, I'm gonna take a title over here, and for title I can take actual versus predicted price. Okay, so let's take plt dot show over here. So as you can see, like for here on this axis, the actual price and predicted price is coming over here. So if we measure the distance over one point to another point, it distance, it's so much minimally low. So because of that, we can say that like the distance between the actual price and prediction price is too much low, and our model is working perfectly, and the prediction will be nearby same because of the low distance over here. all the distance that individual come between actual and predicted are on the same. We can see it is on the same, like same alignment. And our plot is done. Now what we can do over here, we can simply check our pretty accuracy measure over here using the test data. So like what I can do, I will use on test data, accuracy may measure on test data. So what I can do over here, I will take a test data prediction. So for here, what I can do, where I will take a model dot predict, and sorry, it will be like not like that. Is model dot. So I'm initializing the model dot predict on the test underscore data dot underscore prediction. So here I will take x test over here. Sorry. Uh, so if I run it, it's running. So what I can do over here, I can simply copy these two again and paste it over here. So for here, I'm gonna just change the parameters. Like for y train, I'm gonna give y test over here, and for data prediction, I'm gonna use that test data prediction. I'm gonna paste it over here and also paste it over here. So for here, I'm gonna also change this one. I can take x test y test over here, and after that, what I can do, I can simply I can take score 3 over here and 4 over here. So after that, I'm gonna copy this print function over here and simply paste it. And for score 1, I'm gonna place 3, and score 4, I'm gonna place 4. So if we check the R2 score, it's changed, and mean square error also changed. And here we got a mean square error as like a 0.0091, which is a good thing. Like the low amount we get over here, the square value, but here it is a little bit higher. Our R2 error also, like accuracy also dropped over here, like 0.90 coming, and here we got like a 0.99 percentage, which is a good one. But here we got only 90%. On test data, it is coming a little bit low. There should be maybe many reason. Like on train data, we saw that compared to the test data, it is a little bit big. The data set is little bit big comparing to the test data. So maybe that should be the reason also. Like many other reason also lies on that. So like up to here, the model building process and the accuracy measurement process, everything is done for today. So I think it's enough for this model to predict the house price of the that Boston data set. So thank you for being for such a long time.